There are even more ones.
Okay, everybody gets quiet at the appropriate time. I don't even have to ask you to get quiet. Thank you for your attention. My name is Lee Dodds, and this is the weekly University of Tennessee Nuclear Engineering Department Colloquium Program. And today's speaker is a very special person because he is one of our own graduates. He graduated 3 times from this program, BS, MS, and PhD. It's Dr. Tony Buhl, received his BS degree in 1963, MS in 1964, and PhD in 1967. And then he went into the Army as a commissioned officer. He was in the Army for 2 years, and then he came back to the Oak Ridge National Laboratory. He was at Oak Ridge for 3 years. In fact, during that period of time, I was a graduate student, and he and I shared an office together for a few months. He was also on my PhD committee, which was an interesting experience. After his stint at Ornell, he went to DOE headquarters for 3 years. He was with the Nuclear Regulatory Commission for 3 years. And during the TMI accident, he was there along with several other Oak Ridgers, including Dr. Bert Ackerman, who is also a graduate of our program. He spent over 10 years in the commercial nuclear power industry, serving as the President and Chief Executive Officer of Tenera. He was with the Technology for Energy Corporation. He was Vice President for CH2M Hill, in charge of operating the Rocky Flats plant. He was also a Vice President in charge of operations for the Hanford plant. And then 7 years ago, he formed his own company called Energex, and that company still exists today. He is the President and CEO of Energex. And so, ladies and gentlemen, it is indeed a pleasure to have Dr. Tony Buhl. Please welcome Tony.
Thank you, Lee. Especially for the students here, I'll tell a quick story which does have little to do with safety culture, but has a lot to do with graduate student survival culture. I'd been on a couple of, at that time I was very young, it's obvious that I'm 20, 30 years younger than Lee, but nonetheless I ended up on his doctoral committee, and I'd only ever been involved with the master students at that point. And Dr. Pasqua, for whom this building is named now, was the department head, and he was on the committee. And Lee and I had worked together at Oak Ridge during those 2 or 3 years, and so we had the thing which many of you have gone through. With I think there were 5 math professors, Dr. Pasqua, a few others, Dr. Robinson, and so forth. And we were all sitting there. Lee did his thesis act, and he and the department head, Dr. Pasqua, started arguing about whether something that I no longer remember was an initial value problem or a boundary value problem. And this went back and forth, and we're sitting behind a table as if we were there, and Lee's at the board. And finally, in complete discouragement, Lee walked over, put his foot up on the table in front of us, and said, "Dr. Pasqua, I can understand where you're coming from. That's what I thought before I understood the situation." True story about the department head. NASA decided after the Columbia accident a couple of years ago that they needed an extreme makeover in safety culture. They'd had the Challenger accident. They had the Columbia accident that you're all familiar with. 1979, Dr. Ackerman, who's in the audience, and I spent a good bit of time. I was at the Nuclear Regulatory Commission at that time in Washington at a place called 3 Mile Island. We were in the control room during the recovery period together, and that particular event caused the whole nuclear power industry to have the same reaction. That is, we need an extreme makeover in safety culture. So the question today is, does the Department of Energy need a complete makeover, or an extreme makeover, or no makeover in safety culture? Since 1940s, early 1940, some element or predecessor of the Department of Energy has existed. At first it was the Atomic Energy Commission, which, by the way, I went to work for in D.C. many years ago, which became ERDA, which then became the Department of Energy, and from that I spun off with the Nuclear Regulatory Commission in D.C., so there was a lot of change. But in all of that, if you look back at the Manhattan Project, that is the original project to build the atomic bombs in this country, and the race we had during World War II, the Manhattan Project has spun out many, many thousands of projects. And I categorize these in several areas. Obviously, there's the nuclear weapons program, still going today, starting then. Nuclear materials, isotope, medical production, those kinds of programs. Navy, we know about. The Navy also has had its significant emotional events. They lost 2 nuclear subs many years ago, which created a radical change in the safety culture in the United States Navy. A lot of nuclear reactor research. Many of us here worked on the breeder reactor and others. Commercial power, you heard a lot about last week. 1979 was their Copernican shift. And then finally, decommissioning and waste disposal. And I'll talk about those in a minute. First, I want to talk about what's happening in DOE right now. When I walked out of here last week, I attended to see what really happens. I picked up the Knoxville News-Sentinel last Wednesday. There was an article called Double Your Trouble. It was about the Department of Energy. The first line says, Department of Energy contractors have a habit of screwing up things. It seems like it happens a lot. And then it goes on and picks on various contractors in Oak Ridge and talks about the things they screwed up. The Department of Energy is not a monolithic organization. The department has all kinds of pieces, all kinds of things going on. Before getting into what is this safety culture thing, this is a definition I particularly like. And for those of you who are into safety culture, there are a number of books. I brought one here. Jim Reason, that you may know this book, has written a book about managing risk of organizations, and he has some good descriptions. But safety culture is basically that set of collective behaviors, beliefs, attitudes, assumptions that demonstrate an intentional and an overriding priority on safety in everything an organization does. Key words being overriding. In a moment, I'll talk a little about some of the problems in DOE. One of the things I want to show you is our company, in a whole different venue, was asked by some folks recently to take all of the accidents in DOE that have happened in the last 2 years. And by the way, that's over 100 accidents. Fortunately, only 2 deaths in DOE, but over 100 accidents, and analyze the causal factors. What caused those accidents? And what's the collective significance of all that? So I'll talk about specific accidents in a moment. But this is a definition. There are many others. The International Atomic Energy Agency in INSAG 75, to my knowledge, was the first organization to ever coin the phrase safety culture. The whole notion of corporate culture, I'll talk about in a minute. But safety culture came out of the Chernobyl accident. Chernobyl should have been to DOE what PMI was to the commercial industry. It turns out it wasn't quite, but it certainly had a profound impact on DOE. The Nuclear Regulatory Commission has a similar official definition of safety culture now. A good safety culture is a reflection of the values which are shared throughout an organization and based on the belief that safety is very important and is everyone's responsibility. So a lot of research has been done in the last few years on safety culture. What I'd like to do is show you a place I spent a decade of my life recently. For those of you familiar with it, this happens to be Rocky Flats. And in the background you see the snow-covered Rockies, which we recently moved away from. This particular site has had, no longer has, had over 400 buildings. The part of the site you see over here, under this high security fence, is where all the plutonium nuclear weapon hearts of the weapons were made for many decades, several decades. And in there, when we showed up, there were about something over 14 tons of pure plutonium. For those of you who've figured out how nuclear weapons work, you know that's quite a few nuclear weapons worth of plutonium. We also had over 4,000 weapons parts. We had about 47,000 different chemicals in those buildings. This side of the plant is where they made the other weapons parts, that is, the non-plutonium weapons parts. That site is about 10 miles north of Denver. You can stand anywhere on that site practically and see downtown Denver line of sight. It's about 7 miles due southwest of Boulder, Colorado. So the government decided they wanted to get rid of that site and eliminate some 400 buildings. This was our job, and my job here was Vice President of CH2M Hill at the time, was to be responsible for the environmental safety, health, quality, and those kind of things, and the oversight of these various jobs. For those who haven't seen inside a nuclear weapons plant, I thought I'd show you a few pictures that you can't see anymore because none of this stuff exists. This is how we dressed out daily in this kind of respirator and suit. And sometimes it got worse. If you look at the bubble suits, sometimes we had to have supplied air, depending on what we were taking out, tearing down, getting rid of. This happens to be what it looked like in a glove box when you're actually fooling around with these parts. And these tanks are quite interesting because we had over 4,000 of these tanks filled with plutonium solutions. So all of this had to be removed. I would say that's what the site looks like today. It doesn't because the rubble's gone. Actually, I dug a hole and buried all the rubble, but I just show you one picture of what we went through. This entire process started in April of 1995, and the contract for this job ends next year. So that's a piece of what's going on in DOE. Let's talk back about safety culture for a minute. Out of all of those things that DOE's done over the last many years, a number of governance schemes have evolved in safety culture. I'm not going to spend a lot of time on this, but depending on where you are and what you're doing within the DOE complex and within the greater nuclear complex, there are organizations with self-regulation. There are organizations with independent oversight. For example, one of the great impacts on DOE as a result of primarily the accident at Chernobyl was the invention by Congress of the Defense Facilities Nuclear Safety Board, which is kind of sort of like the Nuclear Regulatory Commission, except it's not really a regulator, but you can hardly tell that if you work in the complex. I'd like to tell you what, so that's independent oversight, self-regulation, and of course the industry on the bottom line after 3 Mile Island developed its own separate INPO organization, and it does its own policing now. So that's the radical change they went through. A few weeks ago, this organization called Defense Nuclear Facility Safety Board, which has been in place since 1988, and has issued all sorts of recommendations and documents criticizing DOE. And let me say, it's not my purpose here today to criticize DOE, but rather talk about safety culture. They just published an article, a document on safety culture. The cover letter is dated December 14, 2004. In this article, they say several very interesting things about the Department of Energy. They say the Department of Energy safety is a complex, overlapping collection of regulations, contractual requirements, and guidance. Safety functions in headquarters has become a bureaucracy, and central leadership changes frequently. For DOE and some contractors, affecting change doesn't work. And on and on. I have lots of quotes in here I could give you. Pressure to increase productivity and reduce costs continues. The concern is that changes to relax requirements within DOE and achieve high productivity can increase the likelihood of a catastrophic accident. All that can be said with confidence is that the current trend tends to make a high-consequence, low-probability accident much more likely in DOE than it was before. All of these comments are about the safety culture in DOE and the stress that this particular independent congressionally appointed board has with DOE. Safety cultures have evolved. Safety cultures evolved. The Navy, by the way, as I said, lost 2 subs over time. But the Navy has always been the most formal technically and operationally of all nuclear organizations. Admiral Rickover started this process. I'll show you in a few moments. Rickover on one piece of paper had a list of this is what you shall do in the Navy. I have that list today. If you've been in the Navy or been around the Navy, you'll recognize it quickly. But one thing he did was he formed a priesthood. DOE never formed a priesthood. The Nuclear Regulatory Commission was the commercial priesthood. In the Navy, if you went outside the box, if you were driving a ship and you went outside the box, you no longer had procedures. You knew exactly what to do, who to call, how to make it happen. We never quite achieved that or even tried in the Department of Energy. The commercial plants prior to 3 Mile Island, they all had independent cultures. In this country, we have, I think 103 operating nuclear plants. Every one of them is different. Every one was built to the desire of the utility. Our own Oak Ridge National Lab director, hero, Dr. Weinberg, back when I was younger probably than anybody in this room, used to give speeches about how we really ought to have this thing centralized and focused in the commercial world, and you probably heard that speech a few times yourselves. Never happened, so we have this conglomeration of all these different 103 reactors. Not a one of them is like the other. It might look alike, but they're a bit deceptive, so we have no standardization. Post 3 Mile Island, as I said, the Copernican shift took place. The industry got its act together. It took the industry about 12 years, by the way, from the time TMI happened until they actually got their act together. And you've heard some of the numbers about the availability of the plants as one good indicator. It's gone from about 65% now to about 92%. The weapons program has emphasized security, obviously, which they surely should, technical excellence, but site to site to site, there is great variation in safety culture. I mentioned in 1988 the creation by Congress of the Defense Nuclear Facility Safety Board. There was also a second thing that happened by Congress, and that is they took the Price-Anderson Act, which before that had been extended to the as an insurance policy, basically, to the commercial industry, and they applied that to DOE. So working for DOE now, you can have civil fines and penalties. You can be put in prison if you do bad things in safety space. And nobody's been put in prison, to my knowledge. They've come close. Rocky Flats, before we got there, some of the managers came closer. Lots of trials and that sort of thing, and allegations. Many, many companies have been fined big bucks. Big bucks being maybe $1 million for safety infractions, pretty much across the complex. Oak Ridge has had more of the $100,000 to $500,000 fines at the different places here. So that was put in place, a brand new thing in '88, and it didn't start happening until really about 1993. And the one that is also interesting is nuclear waste operations. There has been a potpourri of safety cultures and approaches to safety over the years. I want to talk for a minute about, before I talk about sort of the accidents and what they all mean in DOE, I'd like to talk about a larger culture. Over the years, in all organizations, we recognize that there are different kinds of people with different kinds of driving forces and views and so forth. So this circle, first of all, this target, if you will, represents pretty much what most of the business schools now agree to are the various organizational cultures in the country. Coercive in the middle. This is the company in which the boss says, "You're my arms and legs. You'll do it my way or the highway. If you don't do it my way, you'll be out of here. We'll get somebody else," and move on. Coercive organizations are top down. The goals are set by the boss, and the problems are solved by the boss. And good news is these kind of organizations, if you look at all the companies in the United States, these kind of organizations represent only about 5% of the companies in the United States. Not many. Interestingly enough, almost all, if not all, government organizations fall into the second cultural category, rules and roles. This represents probably about 60% of every organization in the United States. Well, what are rules and roles? Because that's important, because that's what DOE predominantly is. Now, when I say this, if you go into any organization, you'll find some coercive folks, you'll find some rules and roles folks, you'll find some who are more pragmatic, you'll find some who are principled, so it's not like everybody's in this box. But you can surely determine in an organization very quickly in a number of ways, and very definitely what the culture of that organization is. Rules and roles organization is about rules and punishment. We have rules. Nuclear Regulatory Commission came out of the same thing. We were a rules and still are a rules and roles organization. We have regulations, and if you don't follow them, you're in trouble. DOE has DOE requirements, contractual requirements. They have nuclear safety rules, RAD rules, quality rules, and you don't follow them, you're in trouble. In fact, you'll be fined. And every time there's one of these major hiccups, a lot of people get fired too, by the way. That's been the tradition. So rules and roles organizations tend to also have very long vertical chains of command. I mean, there's a boss who has a boss, and she has a boss, and he has a boss, and pretty soon you're an assistant secretary, and then you're an undersecretary, then you're a deputy secretary, then you're secretary, and if you're secretary, you're not quite sure who you work for. So DOE is typical of a rules and roles organization. I'll just mention the other two, because what happens in companies when we're trying to change safety culture, when we're trying to change any aspect of the culture of any company, what happens is you always bring in some change agent, somebody who says, been there, done that, I know you're losing money, or you're getting fined, or your people are getting uptakes in the nuclear world, or whatever bad things are happening. Hopefully not, we just had another TMI, or we just had another Challenger. But generally those folks come from up here. People who have worked in either principled or pragmatic companies. Principled companies is more about people. It's about engaging your people more. It's about forming teams to solve problems, and a lot flatter and a lot more about using people's heads and skills and brain power than they're just their arms and legs and back at the center, shut up and behave kind of an approach. So without spending a whole lot more time on this, the notion is that every organization has these kind of people. Pragmatic represents about 25% of the companies in the United States, and which only leaves 10% out here where everybody thinks they'd like to be culturally, but they aren't. So I'll give you a quick picture of the overall culture, the kind of cultures we deal with. Again, DOE is primarily rules and roles, and most of the people who want change are in the pragmatic principle. By the way, NASA's rules and roles too. NASA started 2 years ago trying to figure out how to, quote, shift their safety culture. And by the way, they're not there yet. And by the way, if you haven't read the report on the Challenger, it's on the web, and it's just an amazing piece of work where they self-criticize basically and say, what's wrong with them? Well, as I've already covered most of these facts, again, in rules and roles organization, management believes you really have to tell people what to do, how to do it, when to do it, what to wear when they do it, etc., etc. Decision making is, obviously, if something goes wrong, we didn't have enough rules. We need more rules, we need more requirements, we need more orders. And rules and roles organizations do like to have teams for special tasks. If, in fact, something goes wrong, the boss generally says, I don't want to have this rub off on me, so how about the 14 people over here form a committee, and you come back to me in 6 months and tell me exactly what I should do, and by then, hopefully, I'll be promoted and, But in any case, there's this tendency to take those kind of problematic issues and to form teams. Whereas it's the norm in pragmatic organizations to find the leaders and form the teams. And people are seen as being very effective. So with that kind of backdrop on organizations, let's talk about safety. One of the classic, absolute classic arguments that has gone on at least throughout my career, and especially in the last decade or so, is the argument of production over safety. Now, when somebody says that sentence, it's clear they don't understand either, by the way, production or safety, because you can't have production and safety. And I'll get to that in a moment. And the Defense Board I mentioned earlier has spent the last 10 years with the Department of Energy trying to create an integrated safety management system in which there is no production and safety. There's doing work safely. There is no separation. But going back to basically the Brits and some of the good writings on managing risk, this chart happens to be Jim's chart, which I give him credit for in a very small print down here that you can't see. But in any case, what happens in organizations in the old way of thinking was, well, if we're going to put people in one of those rooms I showed you with a lot of plutonium and radiation, and I have to put on this suit and do all this stuff, I probably ought to protect them. And there's great variety, by the way, if you go to places like Russia, back when we were over there with Chernobyl, or if you go to England, or if you go to India, or if you go to wherever, you'll see a great variety in how this protection side of this thing is handled. Now, obviously, and by the way, you can tell this is Brit, by the way, because, see, this is like a highway, and the thing to be is to be on the left side. So just bear that. This is a drive on the wrong side of the road kind of a diagram. But if you're doing a project of any sort, there's always an argument or a trade-off about, well, how much protection do we have to give these people when they do this, in terms of equipment, in terms of how they dress out, in terms of whatever, versus getting the job done. Now, we have the terminal left-brain project managers who always say, hold my coat, let me at them. You know, what is this safety stuff? It gets in my way. I don't need it. Why do we need these rules anyway? And then we can also have folks on the other side who are equally immature who say, oh, look, our job, and by the way, DOE was this way around the change in 1990 when the Navy came in and basically took over DOE. They brought a whole different set of thinking. It's kind of the, do safety and work if you can kind of attitude. So when you start a project, you always have the safety people around, you always have the project managers around, and everybody says it's going to be the safest project in the world. Been here, done this, it's going to happen. And things go along and they get behind schedule, and pretty soon somebody says, you know, if we would just quit doing this, this, and this, we could get this job done. And sure enough, the word drifts down and around, and they quit doing this, this, and this, and all of a sudden, somebody gets hurt, somebody gets cut, something happens, and people get excited. And the safety folks always say, I told you so. We got to go do all of this and get back on the left side of the road so we're driving and not hurting people. And guess what? Same thing happens over time. The project goes along, kind of drifts back to the middle of the road, and then splash. We got a $1 million fine. The boss doesn't like that. Whatever. We injured somebody. We had one at Rocky Flats. I'll never forget my first week on the job. We had a fellow whose habit was to sit in a trailer, and we had a lot of trailers for all these in lieu of offices. His favorite thing in the morning was he had a hot plate, one of these little apartment one-eye hot plates under his desk. Kept his feet warm. And he always liked to read the Denver Post. And one morning, he heard his boss's voice and didn't want to be caught with the Denver Post, so he threw it under the desk and set the whole trailer on fire. And that's one of the more minor accidents we had during that period. But I mean, those kind of things happen. You say, how could this guy throw? You know, that kind of thing happens. Well, what really happens eventually in this process is what happens over here is Chernobyl or TMI, Challenger, Bhopal. And when you get to this stage, the world says, people that are no longer in the organization say, this got to change. We're not going to do this anymore. We're going to change this or shut this down. So that's where the whole culture issue goes to. Well, what have we learned about safety culture in the nuclear business broadly? First of all, there is no single nuclear safety culture, nor necessarily should there be. All operations like to think they're standards-based and risk-informed, the new buzzword. That would happen to be my job at NRC, by the way. I was the first director of risk assessment, which was fun because in those days, for some of you may remember, we were doing the WASH 1400 things and that sort of thing. And Dr. Fontana on the front row and I had a lot of fun with doing the follow-on to the TMI. We did lots of risk evaluations and that sort of thing. But in fact, they're not all that well risk-informed. The formalization varies. As I said, the nuclear Navy is very formal. And some of these I probably shouldn't spend a lot of time on. There's almost an inverse correlation between the degree of formality and political mission uncertainty. When things get very uncertain, big problems happen. And there's sometimes when you look, and this is something I'll just leave dangling, but sometimes when you look, there seems to be an apparent similarity of a lot of mechanisms in these different agencies, different organizations, nuclear organizations, but they're really not. They just kind of look alike. And we peel back the first layer, you say, oh, no, is this happening? Is that happening? Well, sources of some of this cultural variability across, whether it's DOE, the commercial plants, weapons plants, whatever, is caused by a phrase I like to use, which hopefully you haven't read heretofore, called unconventional uncertainty. When we're doing jobs, you know, in the commercial world, we kind of learn to design, build, and operate nuclear plants. In fact, when I was young, we thought that's all there was to it. We're going to design, build, operate 1,000 nuclear plants. And actually, at the DOE's predecessor in the DOE, there was very little interest in the early days. There were certainly some people who were very interested. They had very little interest in what are we going to do with the waste? How are we going to handle the problems we're creating? And at Rocky Flats, well, we got a trench out here. We'll just bury it right here down the road. And some of us had the good fortune, or at least interesting experience, of digging up a lot of that stuff. But there was very little emphasis on that side of the equation. It was design, build, operate. In design, build, operate, you have a lot of conventional uncertainty. That is, we know what to do when we're building a bridge if we have bad weather, or if the guy drops the beam off the truck. I mean, those kind of things happen, so you go, hope nobody got hurt, you redo it. Conventional things happen, and we have precedents for them. And so we know how to deal with that. What happens on the other end of the spectrum, when you saw the photos there at Rocky Flats and many other sites, Hanford's no different, dozens of sites out there are the same, whether it be weapons sites or other cleanup sites. You're suddenly out of conventional uncertainty into what I call unconventional uncertainty. That is, you suddenly you're doing a job, and all of a sudden, at one of these plants, you say, gee, there's an interesting drum. I wonder what's in it. And, of course, the person you talk to is usually the facility manager or some such person. And she says, oh, nothing. That drum's been there for years. This actually happened to me. And you say, really, what do you use it for? Well, we've had it there because, when we go into the back area through the step-off pad where we're going to actually deal with these materials, we needed a place to tie our shoe. And so putting her foot on this drum was a great place to tie her shoes. So in one of these cases, I insisted that we bring some people in and open the drum. And guess what? It had a big hot polonium beryllium source in it, totally unmarked. And you say, oh, well, I could tell stories much worse than that. But in any case, these kind of unconventional things happen. It's not enough in an unconventional situation like that, surprises, discoveries, to say, oh, stop work. Everybody has stop work authority. Right. And by the way, that's generally true in every nuclear facility. However, the real question is, and now what do I do? You know, I just discovered this or that or the other. Now what do I do, and how do I get out of this? So unconventional uncertainty makes this even more difficult. Risk management is not done well, typically across the complex. There are some good examples, and anything I say negative, there's always some good examples. There are some great people in DOE, by the way. But in general, there is no sort of cultural understanding that we really need the risk. It's gotten much better in the last 2 or 3 years, I think, with some of the, actually, I could brag, I could say with some of the my Rocky Flats colleagues, having spent a few years in D.C. as undersecretaries and various other positions in the Department of Energy, but that's all gone again, and we're starting over, as all of you know, with a whole new array of people. We'll see how that works out. Risk management's not done well. And until very recently, this notion of a safety culture has been mostly viewed as apart from and sort of this touchy-feely person thing aside from the real work. Those are 3 words I learned to hate over the last 12, 15 years at Rocky Flats and Hanford. There's always the real work. Now, the real work is always done by those people who say, hold my coat, by the way. It's the same group. It's the 101 project management folks who have little appreciation for the safety part of life, and certainly who haven't yet understood the integration of it. Well, so all these approaches to safety culture boil down to basically these 4. They're sort of behavior-based safety things we do. Examples of that would be radiation protection. For many, many years, we've understood in nuclear facilities that radiation protection is really about the behavior of people, how we monitor it, what we do. It's very much in the face of the people doing the work. Performance-based, you heard some of that last week, particularly with the commercial power plants. These plants are up and operating. They're doing better than they've ever done in the history of man. They have very low outages, maybe 18, 20 days now. They have 92% factors, so they're doing well, and they're very much performance-based safety. Discovery-driven, what I was just talking about. The early Navy program was discovery-driven. The nuclear weapons program back in the days, if some of you are into criticality safety, you should certainly read Bill Stratton's book. I'm sure you have. From the early days when there were crit events everywhere, all over the United States and around the world, there were all these interesting, unbelievable criticality events. Those aren't happening very much anymore. We know about the one in Japan, but a lot of discovery-driven stuff. TMI cleanup was discovery-driven. I still have the logbook. I remember the first day we walked in the control room, and Dr. Ackman and I were talking to some of the operators at one point, and I even remember Ivan's name and others, and I drew this cylinder in my logbook. I drew an inverse cosine curve, and I said, you know, guys, this is where your core is. That's almost the bottom of the core. And they almost beat me up in the control room because they were absolutely convinced they had not melted that core or seriously damaged that core. This went on for days and days, not just a few hours after the accident. So that mindset is there. The last one I call a hybrid system. Here we have a system in which DOE regulates itself, but this thing I talked about, the Defense Nuclear Facility Safety Board, recommends. And by recommends, what it does is it writes articles like the one I just showed you and sends them to the Secretary of Energy. And if any of you happen to be an Old Testament fan like Amos the prophet in the Old Testament, you know, he always started his sermons for 3 transgressions and for 4. Well, that's what they do too. And then they say, it's your fault, DOE, and you really screwed it up. And they've done a pretty reasonable job in bringing some of this stuff along. By the way, several years ago, we got into this. I had an example here. Maybe I'll never see it again. We got into this argument about DOE. The Secretary of Energy decided 10 years ago the DOE could no longer self-regulate. She had the board helping them, the Defense Board, but she came out with this notion that the Nuclear Regulatory Commission should regulate the Defense Board. So a couple of friends of mine and I sat down following all of this And we wrote an article, and I can't even remember how it happened. Somebody from Nuclear News called me, I think, and we wrote an article about this, and we were surprised. It ended up on the cover of Nuclear News. It's a big nuclear regulation of DOE, the big NRC stamp across it. And it was clearly a balanced article, not because I wrote it, but because I got calls from the Defense Board saying, we are really glad you're on DOE's side in this thing. And the same day, I got calls from the Nuclear Regulatory Commission saying, we're really glad you're on NRC's side in this thing. So we came out unscathed, basically. But this debate still continues. Who should regulate Department of Energy? Right now, it's self-regulated with recommendations. So those are the four basic places it plays out. And I've already said, all of this kind of distills down to three manifestations of safety. One is, and by the way, this is the way it was in many places in the old days, get the work done and do safety if you can. You know, be safe if you can, but we got to get this job done. I remember I had an old man in the Army who would say, look, Tony, you know, we have to go through a few. Don't worry about it, you know. I mean, we got to get this job done. Fortunately, we don't play that way much anymore. Then came along the belief system across DOE that in the early 90s that we're gonna do safety and work if we can. And you can imagine where that led to in terms of workspace. The real key buzzwords that finally have caught on is do work safely. And the Department of Energy, with a lot of push from the Defense Board, has created an integrated approach. I'll show you in a moment. Well, most of these descriptions of safety culture across the nuclear complex have addressed the technology. They've addressed regulatory needs because they get beat up if they don't. They certainly have addressed, in some cases, peer expectations. The commercial industry is the best example with INPO. And as I said earlier, they really do not articulate the enterprise risk very well in an overall way, and they do not deal very well with this thing I call unconventional uncertainty, or the exploratory risk, the things that pop up, the discoveries, the surprises as we go along. Rickover always said these things. He said, we're going to have rising standards of safety. We're going to be technically self-sufficient. We're going to face the facts. And we're going to respect the very smallest amount of radiation, wherever it is. We're going to train constantly and ceaselessly. We're going to apply total responsibility. You know, we don't get into the game that, gee, this happened, but it's really their fault. The amazing thing about major events that happen to organizations, the first sign of a bad safety culture is the first 10 people you talk to will tell you why it's somebody else's fault. And it's always outside the organization. It's the regulator's fault. It's somebody else's fault. Blame springs eternal in the human being. You know, if we can blame people, then we can maintain the status quo. That's kind of how most of us live. And I've said for many years, you know, all systems conspire to maintain the status quo. So in organizations are very difficult to create change in. And develop the capacity to learn. The new principles at DOE are these. Line management's responsible for safety. We who do the safety work, who do the oversight, who create the policies and so forth, are there to support them, to help them. But line management has to be responsible for safety. Competence is a big issue. Identification of standards and requirements has been an overblown issue in some ways, but it's extremely important. Hazards controls need to be tailored for the real work you're doing. In the old days, we would have these magnificent documents about 3 inches thick that says if you want to move a ladder from point A to point B, all you got to do is read this 3-inch document. And by the way, give it to one of your worker persons who, you know, is never going to read a 3-inch document, and they'll read it and they'll be able to move a ladder from point A to B, or take the square root of 2 or whatever it is they're doing. So now we tailor those controls to the real work that's being done. Operations authorization is a bit like licensing. There was no mechanism within the Department of Energy 10 years ago to authorize work. It was just, okay, we're going to go do it. Let's all team up, and we'll run Primavera or something, and we'll have all the actions laid out, and we'll just do it. Now, shaping a safety culture, the interesting thing about this is you have to have a good base of requirements, which are well understood, reasonable. And most managers in nuclear organizations focus on two areas. One, do I have all my requirements straight? And, by the way, have we killed or injured anyone? It is amazing in the management of nuclear enterprises how we do not deal effectively with near misses, and how we have these first aid cases over and over and over, and we don't look at them as precursors to bigger and greater and more horrendous problems. So in shaping a safety culture, bear that in mind. What I'm going to talk about now, I'm not going to talk about the accidents. If you want them, they're all available on the website, depreb.org. You can go in there and see all the accidents that ever happened in the Department of Energy, anytime ever, wherever they happen. But as I said earlier, we were asked to take a look at the last 2 years. And the last 2 years have been slightly over 100 accidents in DOE. And as I said, fortunately, or unfortunately, depending how you look at it, only 2 deaths. But there have been some very serious accidents within DOE. So we asked ourselves, what are the causal factors? DOE and Congress and a lot of people are wondering, what can we do to change the safety culture to make it better? Well, interestingly enough, some of these causal factors would not be what you might expect if you were just focused on safety. One of them was just poor contract management. Inadequate commitment, even though the board and DOE have created now what's a reasonable integrated safety management approach to dealing with safety, many contractors don't bother or only give lip service, or don't understand it, as the next point is said. Every organizational engagement, which have been many in my career that we've been involved in, where an organization was either shut down, being shut down, trying to start up, had an accident, whatever, I have never seen one where this issue of communications was not a core issue. Communications break down. Expectations are not documented, they're not understood, and when you go back after the fact, it can be very sad to sit and listen to people who are very brilliant, very intelligent, have degrees from the University of Tennessee and other places, and you say, how in heaven's name did we end up with this kind of communication breakdown between human beings who were dealing with each other? This is always one of the top 5 causal factors of every accident, every problem that we've ever seen in the last 30 years. Expectations are not understood, part of communications, and often work is not sufficiently defined. Goes back to the hold my coat, let me at 'em theory. A few more. We've certainly found cases in these 100 accidents plus where safety culture issues either weren't identified or they were identified and just not dealt with. They were just kind of left on the table for months and months and months and years until something self-destructive. The infrastructure, that is, the actual systems that people follow, were flawed in some cases. The favorite, one of the all-time favorites of the Defense Board is this one. People declare that they're ready to do work when they're not. That's one of the major causal factors. Work processes, always one of them. And here's the key one. Those of us who've spent a lot of years worrying about risk assessment, risk evaluations, it's always about hardware and operators and people and how do we make this equipment work, or how do we produce power, and what are the single failures, and what are the event trees and faults, all of that. But when you trace a lot of these accidents back, you find that in the planning process, there was zero thought about risk management. Zero. Because the belief was, okay, we're doing the planning for this big evolution. We're going to take these buildings down, or we're going to build this facility. And when it gets to these engineers, they're going to figure all this stuff out, this risk stuff. So the lack of planning, not being risk-based, is one of the key. Well, very quickly, this is the oldest chart of many thousands that have been drawn now of integrated safety management. What it says is before we start working on these jobs, we're going to define the scope of the work. We're going to analyze the hazards. And by the way, there's a loop that goes back here that's very important. It says when we analyze the hazards, it may be that we can't do the scope of work. And people forget that very often. And then we're going to develop controls for that. We're going to have people actually do the work. And we're going to have a whole set of feedback mechanisms to tell us what we learned that we can feed back into this logic. So this is the basic logic that DOE follows nationwide now. Some sites better than others, some managers better than others. Why did they create this? Well, they had to compensate for the lack of a design basis. Most DOE facilities do not have a design basis, as we would know them, say, in a commercial world. They had to define a licensing process. One does not exist. There is no licensing per se in DOE. They had to remedy these planning uncertainties that I talked about, and often there were confused requirements that had to be sorted out. So now these are the kind of bottom line safety values. And by the way, if you want to pick one company in industrial health and safety space that changed its culture a long, long time ago, that would be DuPont. Dr. Dodds and I and maybe others worked for DuPont at one time or another. DuPont founder blew himself up at Brandywine, decided to go in and save this plant and blew himself up, and there was an emotional event. He just lost the founder of the company, so they got very serious about safety very early. All accidents and injuries are preventable. Exposures to people and the environment are controllable, and risk can be effectively assessed, handled, and communicated. Big breakdown in this one often. Near misses and other deficiencies can be captured, acknowledged, and promptly corrected. Continuous improvement, lessons learned. What do we learn in feedback? And safety has got to be the core of our risk reduction business. We look at a job we have to do. There's two things, and people often get, hazards and risk mixed up when they talk about it, particularly if you hear it on TV or you hear it just in the general class. Somebody says, well, there's really a risk at Hanford because we've got 2,000 plus tons of plutonium fuels sitting within literally a stone's throw of the Columbia River. Well, that's a hazard sitting there. The risk is what do we do to get it away from there? And we often forget that anything we do, we can create more risk than anybody could by leaving something. So you have to really work through this notion of risk reduction. Okay, what's the salvation? Once you end one of these sermons, I've kind of dumped on you all the pros and cons, and it may sound very negative, but I can tell you DOE is making a lot of progress pretty much across the country, not that there aren't still a lot of problems. This chart is something we did for NASA. This discussion today was not about NASA, but as I said, NASA is in the middle of a major league Copernican shift. It's been traumatic. They don't know what to do. We're almost not in the space program now because of the Challenger and more importantly, the Columbia accident. Well, here's some interesting kind of closing points for anybody that wants to go into an organization and make a change. First of all, people don't want to change. People resist change. All of us do. Because it makes us different somehow, and it's a little scary. Without a lot of detail, there was a big investigation of the Columbia accident by the Columbia Accident Investigation Board. They have a One NASA program, a Return to Flight program. They got Lesson Learned program. There's all kinds of things in NASA that look a lot like DOE. It's a high-risk business. So the board said, by the way, here's how we are today as NASA. We're reactive. We produce a lot of data but not a lot of information. Our managers resist information. Everything's oversimplified. We don't have redundant systems. We don't have redundant processes, so we kill some people. Again. Well, the next thing companies want to do, and it's the same with nuclear safety culture, let us figure out where we are and where do we want to be. So NASA had thousands of people working on this, by the way, and so they put together these are the principles. This is where we want to be. We want to have shuttle flight safety being everybody's responsibility. We want our leaders to commit to demonstrate safety. We want trust in our organization. I won't read you all the details, but People can always create a vision. Now, one of the things we find in organizations when we go in to look at the safety culture is we find two things. One is every company with minimum of effort and time can create a great vision and mission. This is the state we're going to be in 3 years or 5 years. They do that with great beauty. I mean, it's almost to the point now you have to have your own buzzwords, and it's hard to find new buzzwords. So this part of it, you know, is relatively straightforward because people want their organizations to be better and safer, right? The hole we find often is they don't do this part at all. When you ask a company, well, where are you now? You see there's an assumption that we all know where we are now, so we don't have to worry about that. That's the first big failure. Second failure is once I know where I am and where I want to be, all I have to do is create an action list, right? And if we do all these good things, just like magic, you know, flipping on the TV, we'll be from point A to point B. Wrong. What happens is this is an experiential process. This transition thing is very experiential because in simple terms, it comprises three pieces. I always ask companies to make a list of what you're not going to do anymore. What are you going to stop doing? And they look at me like I'm an idiot. What do you mean? Well, we have to do all this stuff. We've got these rules. We've got these regulations. You have to do this stuff. Well, if you have to do all this stuff, well, I might as well leave because you can forget it. Because you have to do all this stuff. You don't have enough people to do this other stuff. And plus, we don't know what this other stuff is. So the notion that there are things you have to stop, you have to end, is a step most companies miss, most organizations. People go into a neutral zone when faced with great trauma. They become immobilized. It's much like a terminally ill patient. When a big event happens, an accident, people get killed, people get injured, people become immobilized, demoralized. After that, it doesn't work for a while. They get angry as all get out, scream and yell at each other, and then they finally get to the part to terminally ill patients who says, you know, please God, let me live. Let's bargain. How about it? You know, I don't think your way will work, but your way might work. And how about if we compromise and do this and that? And then finally, they calm down and go to testing, and sometimes that process takes 6 months, and sometimes it takes 6 years. But they always go into this neutral zone where you have to overcome confusion, embrace new direction, new visions, new beliefs, and it's only then that you can start to change. So this is a process that we drew up a couple years ago, about half a dozen of it, and it's a process that NASA is trying to go through now, struggling as they are, and it's a process we've examined, and there's a lot more detail. I just kind of show you the top-level thinking here. But it is an experiential process, and it's very, very, very difficult. So since my time is up, I'll say thank you very much and take any questions.
We have time for questions and comments.
Yes.
DOE, you also talked about the DFSD, which is more towards the NSA.
Yeah. And I've got some noise behind me, so a little louder would help too.
How do we translate this into the national laboratories? We don't have the oversight of the NFSD.
Mm-hmm.
Now, Patel has embraced some of these same philosophies, all accidents are preventable.
Mm-hmm.
And the scientists love to tell us, and they can come up with every scenario.
Mm-hmm.
So how are, from a national lab perspective, is there some things that are different? Is there some ways we can measure it differently? Because we're struggling with that right now. And what would your thoughts be as a national lab versus one production facility?
Okay. Let's take Oak Ridge National Lab. Is that a good one?
That works for me.
Okay. I'm somewhat familiar with your SBMS system there, which I guess was transitioned down from PNNL at Hanford. But the first thing is top management, and I mean the director and all of, in this case, his direct reports, have to recognize that they're on a burning platform. Have you read Managing at the Speed of Change?
Not yet.
You should read that book. It's a great book. I was actually over there. It's a long story, but it's about a guy who was on a burning platform in the North Sea and jumped into frozen water for about 5 stories. And they asked him why he did it. He said, "Well, I had no choice. I'm up here and things are burning up. Maybe you're going to be burned up, or I'm going to jump in and take my chances." So it has to be. I think there first has to be a top management commitment to that. I think your SDMS system has to be fixed. There are some gaps in it. There's some holes in it. And you have a big difficulty in any organization. And by the way, I admire Patel UT greatly out there. I think they've done a tremendous job. And if you don't believe that, you read today's paper. I mean, there's a great article in there about how you guys got 94% and all that. But that commitment at the top, fixing SDMS, is kind of the easy part. The hard part is you have people who have worked in the environment that they've worked in for years. See, the really bad thing about culture is we all got where we are, and we do it the way we do it because it made us successful. And that's why it's so difficult. So you go down a layer, and I won't mention any names, but you go down a layer below kind of the enlightened folks, and I'll let you make that list, not me, and you find that nobody cares. I mean, why should I worry about this? So I think the prescription is that top management has to create a burning platform. It has to cost you more to stay where you are. I don't mean in dollars. I mean in your career, in what you do every day, and how you get safer than it does to change. And it takes a major league commitment, and it takes this kind of an experiential process to get people there, because they won't just leap with you. Anytime. Is there any way I can draw on this screen without a chart on it? Is it possible to get a blank screen real quick? No, I'll draw it on. Try some other view graph. Let's back up. I'll just show you one quick thing. Anytime you try to do what you're asking about, that is, go from where you are to something that I'm sure, I know ORNL can define quickly, because the people are very bright. I know many of them. What happens is your people break down into 3 camps. They will my rule of thirds. It'll always be 1/3, 1/3, 1/3. 1/3 of the people say, right on. We want to have a safety culture. We want to create something different. We want to make this better. Those are the pioneers. Yeah, I'm going over that mountain. Okay. 1/3 of the people will be with you once you define beginning and end. Then you have the settlers. The settlers say, if those pioneers survive, I may go over the mountain. But right now, I'm going to hang back in the weeds and watch and see what happens. And I don't know about those folks. And then the other thing you have are the outlaws. And guess where management spends all of its time? What would you guess? On the outlaws. Yeah. That's what you should do with the outlaws. Shoot.
Okay, do we have any other questions or comments from the local audience? I have a comment from cyberspace that it's not a question, but it came in about 3 minutes before you made your comment about the safety philosophy at the DuPont Company.
Oh.
And this comes from a former DuPonter, namely John Church at Savannah River. And he says, it's satisfying that Tony's third bullet regarding doing work versus safety, namely do work safely, is what DuPont stressed from day one 50 years ago at the Savannah River site. It was the defining principle of their operation, as several of us can attest to. And then he makes the comment, glad to see that more organizations are finally coming around to that safety culture. This is from John Church, and he's looking right now. Hi, John. Okay. Are there any other questions or comments? Ted?
Yes. What about integrating people that are doing the actual work into the process of how to come up with safe ways of working? Because I know in situations I've been in, there's this big juxtaposition between management and the workers, and they feel like the management doesn't really understand what they're doing. They've never done it, and they're trying to tell us to do it, this particular way, and they don't necessarily see that it's any safer than the old way they were doing it, for example. I know that American Airlines, they've been going through some of that process just in the general management, it's been really successful because they've included the workers in it. Your opinion on that?
Well, I mean, you put your finger on the heart of the matter. I mean, first of all, they're right. Often, you know, as managers, we don't know what we're doing, and we walk into places like the ones I showed you and say, I can't believe this. But it was not until, at Rocky Flats, it was not until we did precisely what you're suggesting. We said, we can't have this anymore, where a bunch of people sit off over here in the building and design work and create work packages and hand them to people who do the hands-on work and watch it self-destruct. It's not their fault. So we started a process very early on of saying, okay, every piece of work we plan, every evolution, we're going to go to the workers, we're going to sit down with them, not only that, we're going to walk through this work with them. So we formed teams which were comprised, you know, it depended on the situation, but generally we'd have a rad person. We'd certainly have 2 or 3 of the people that really do the hands-on work involved, and depending on what else. But we would always have a team of 6 to 8 people walk through every piece of work, look at it, say, what are we missing here, what could go wrong, and so forth. So it was not until we got into this enhanced worker safety role and engaged all the people on the floor in what we were doing that we had any progress. Up to then, you know, we sat around wondering why we couldn't get anything done, or why if we did it, we screwed it up. So no, you're right on. I mean, that's an integral part of integrated safety management.
We have one more. Well, this is a question from cyberspace, and even though we're running short of time, I have to go ahead and read this one, or I will get in trouble. This question comes from Mark Dodds, who works for General Electric Company and Global Nuclear Fuels. Why didn't DOE simply adopt the integrated safety analysis regulations promulgated by the NRC?
Hi, Mark. Well, I don't know, and I have to say I don't know. I think what you see are 2 different cultures. I think you see a culture in the commercial industry that had a major significant emotional event at 3 Mile Island and reacted to it. 3 Mile Island had almost no impact of any relevance to the DOE. It wasn't until Chernobyl that DOE got the notion that there might be some nexus within reactor in some of the facilities within DOE. And quite frankly, unlike NRC, unlike the nuclear Navy, the DOE does not have the priesthood that I talked about earlier, and therefore does not have the drivers, such as the bottom line, people like Bill Lee at Duke Power and visions they had about we have to self-regulate, we have to do this thing right. So DOE does not have, even today, the central priesthood that the commercial industry has, and I think that's the basic difference. You're looking at 2, even though the public looks at them, these things are all nuclear and they have the same culture, it is not so. I think you're looking at 2 radically very different cultures.
Okay. I think with that, we need to conclude today's session. I do see a few new faces. I even see Tony's son in the audience, and so let me remind everyone.
And daughter-in-law.
And daughter-in-law. We do have a reception downstairs on the 2nd floor, and everyone is invited. But before we adjourn, let's express our appreciation again to Tony for his presentation.
No.
Right, downstairs.
Okay.
Take you down there.
All right. I'm going to grab my. I'll come back up and get this.
You can come back. It'll be here when you come back.